Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good in your studies. So, if I am talking about the ongoing chapter that we are studying, we have completed two major parts of electromagnetic induction. In first lecture, we have studied about Faraday's law, Lenz's law. In the second lecture, we have studied about motional EMF. Majority of the part we have studied about motional EMF. When I am rotating any conductor, then what will be happening? All these things we have covered in second lecture. Now we are entering into the third lecture, where we are going to study about very important and the third element or the third component electronic device that we are going to introduce, that is inductor. Firstly, I will check the sound, that if it is coming clear. Okay, it is very clear. Fine. So we are good to go for the inductors. Now, what is the inductors? From the past two lectures, we are again and again studying a term that is induced. That is induced. What is induced? Current got induced. What is induced? EMF got induced. So what is this induced? It is very much related from this topic, that is self-induction. Let's understand again by an example that whatever we have studied. Let's summarize that. See, what is the case given here? Finally, our pen is working, guys. So it's very good news for us. Touch wood, touch wood. See, current is flowing through a conductor coil. Current is flowing through this coil. It is a kind of rounded coils is there. It is the same kind of, if you were watching this properly, it is a kind of, I can say, solenoid. Okay, because we are going to use that result as well. Why I am comparing this with the solenoid, that also is a very important thing. Case 1, whatever it is given, that current is increasing, current is flowing in this way, and now it is increasing in this direction. Correct, it is increasing in the forward direction. I hope that this is clear to you. So what will be happening if current is increasing? What I can say, what is the magnetic field? Magnetic field is mu naught Ni for a solenoid. That means I can say if current is increasing, magnetic field is increasing. If magnetic field is increasing, what I can say, flux is increasing. And you know, students, from the first and second law, flux is increasing. That means there is mandatory to induce some current as well as some EMF as well. Now, what will be the direction of the induced current? That is the second question. That's why we have studied about Lenz's law. Lenz's law states what? That it will always oppose the cause who have generated. That means if the increase in current have generated it, that means the induced current will try to decrease that magnetic field, or that will try to decrease the increase in current. How it can decrease? Simply, it can decrease if in this forward direction current is increasing. That means it will induce in such a way that the magnetic field is going to decrease this. Correct. If you will check what is the direction, normal direction of magnetic field is in this direction. In forward direction, there will be a direction for magnetic field naturally. So induced magnetic field will be induced in such a way from this direction, so that the induced magnetic field will be in this direction, so that it can reduce this magnetic field. That means I can say simply this is the direction for the induced current. Okay, it always opposes the cause who have generated it. Clear? Let's see the second case. It will even make the things more clear. Now, in the same forward direction, what is happening? Current is decreasing. In the forward direction, current is decreasing. Current decreasing, magnetic field decreasing, magnetic field decreasing, flux decreasing, flux decreasing. That means there is change in flux. Change in flux, that means current got induced. Current got induced, EMF got induced. But what is about the direction? What about the direction, students? It will induce in such a way that it is going to oppose the cause who have caused it. Actually, the decrease in current have caused it. That means it will induce in such a way that it is going to increase the current. Clear? Now, we have discussed so many times that I guess that till now it is mandatory for you to be clear. Okay. So it will induce in such a way, the induced current will induce in such a way such that it is supporting this current. It will try to increase this current, because actually decrease in current have generated it, so it will always try to increase this current. So it will support the decaying current. Correct now? Fine. So now let's understand some important points. This induction, self induction, that automatically due to the change in current, due to the rate of change of current, the induction that is happening inside the coil, that property of coil is called as self induction. And the coil that we have used here, that coil is used, it's called as actually inductor. Now let's understand some basic things that we have already studied. Let's summarize this once again. Self-induction is a property of current carrying coil that resists or opposes the change in current flowing through it. Of course, it is the basic property of a conductor to resist the change in current. Okay, if it is increasing, you will decrease it. If it is decreasing, you will increase it. That is the natural property. Second one, this mainly occurs due to the self-induced EMF produced in the coil. Of course, I have told you a lot of time, whenever flux will be changing, there will be some induction of EMF will be there. The self-induced EMF in the coil resists the rise of current when the current increases and vice versa. Obviously, the past two cases was explaining about this only. The property is applicable for a time-varying current and not for the direct current, steady current. Of course, if there is no change in current, that means there is no change in magnetic field. If there is no change in magnetic field, there is no change in flux. There is no change in flux, that means there is no EMF generated. There is no EMF generated, there is no induced current. So why to worry? That means it will only come in which kind of cases? Time varying current. That means I can say, if my change in current is there, that means, can I say this little bit, I can say that EMF that is induced is directly proportional to the rate of change of current. Correct? And exactly this is what is going to give you as a formula also. So but formula is one thing, but if you can derive that also just by your thought process, that is a magnificent thing that you can do. Okay, if you are able to understand the things on that level, then you can do anything here. See, so let's derive the formulas and the units, whatever we can do. See, what is the formula? We define that now let's come to the formulas. We define that flux that is here, flux is directly proportional to the current. Flux is directly proportional to the current. So when we remove this proportionality, we have a constant that is represented as L. That is represented as L. And I can say this L is nothing but the coefficient of self-inductance. This is called as coefficient of self-inductance. Coefficient of self-inductance. And L can be defined as flux divided by I. Flux can inductance, self-inductance can be defined as flux divided by I. So if there are n number of turns, you will simply multiply the value with n, and because there are lots of turns are there, it is a kind of solenoid, so you can define it with n. There's no problem into that. Okay, so now here you can derive the units also. What will be the units? For phi, what is the unit? Weber. For current, what is the unit? Current. That means what will be the unit? Weber per ampere. If I am talking about the dimension formula, simply you can use the dimension formula for flux and then divide the dimension formula for current, that is simply A. You can derive the dimension formula as well. If I will ask you, tell me something more about important about this, I can say, if I know about flux, can I say I can write about EMF also? How I can write? Because I know that what is EMF? EMF is nothing but, from Faraday's second law, it is nothing but minus of d phi by dt. Minus of d phi by dt. So what I will write here, what I can write, d phi by dt. L is a constant. I can differentiate dt, and there will be a minus sign that will always represent that it will induce in such a way that it is going to oppose the cause. So this is the very, very important formula for EMF that is generated. EMF is equals to L di by dt. And I have told you also that the EMF that is going to generate will be directly proportional to the rate of change, because you have seen that if it was decreasing, EMF will induce in such a way that it is also going to decrease. It is going to support it. Correct. If it is increasing, it will always try to again oppose it, it will try to decrease. So I can say the rate at which current was changing, EMF was also coming proportional to it. That is very obvious thing, and the formula also giving us the same thing. Correct. So same thing, EMF is explained as here phi is used, that's why negative sign is not represented. Otherwise you will always use a negative sign with it, L di by dt. So whenever you have to write the potential difference, because why I am telling you this formula is EMF, when we are going to apply KCL or KVL, mostly KVL, then it will be used a lot. How I can write the potential difference across a battery, that is L di by dt. Okay, and if you are going in the direction of current, conventional direction of current, you will be always writing minus of L di by dt, just as you have written for resistor. If I'll ask you to tell me write the potential difference across a resistor, how you will write? IR, minus of IR. If I am going in the same direction, we have studied it in complete depth in current electricity. So same way you will be writing the potential difference here. It will become important when you are studying in KVL, and of course we are going to apply KVL not only in this chapter but also in the next chapter as well, that is alternating current. Lots of the things that in alternating current we are going to do, we are going to introduce inductor as well. Now whatever the circuits we will be understanding, we will be understanding for resistor also, capacitor also, and inductor also. Now all these three will be coming simultaneously for us. Okay, so let's see what are the applications. Firstly, let's solve a very basic question, the formula that I have told you from that. Find the induced EMF VA minus VB. This is point VA, this is point VB. You have to calculate what is VA minus VB. VA minus VB is equals to minus of L di by dt. Minus of L di by dt. What is L? L is nothing but 3. What is di by dt? Di by dt is nothing but 3. So what you can say? It will be 9, simply 9 volt. 9 volt will be the answer. Correct? 9 volt will be the answer simply. Now solve this question. What is the question? A solenoid has number of turns. Firstly, always read the question patiently. Okay, there is no hurry. Read the question. Try to write the given things that are present there. Okay, let's write the given things what are present here. What is the number of turns, students? Number of turns is given as 1000 turns. Then when a solenoid of current flowing through it is 4 ampere, through it magnetic flux linked with each turn of solenoid L is given as 4 into 10 power minus, flux is given as 4 into 10 power minus of 3 Weber. The self-induction of the solenoid, how much self-induction of the solenoid is there? How you will be calculating? You will be calculating simply flux is equals to L into I. That means L can be written as 5 divided by current flux and multiplied by number of turns also. Now just solve it. It will be 1000 into flux 4 into 10 power minus of 3 divided by current, that is 4 cancel, 10 power 3, 10 power minus 3 cancel. I guess the answer should come as 1 Henry, simply 1 Henry. That means option B is correct. Clear? Basic formula application. So how the formulas are applied. Anyways, we will see a lot of good questions, good standard questions in the question series from the NEET level to CET level to JEE Main Street, JEE Advanced level also. We'll be watching the questions in the live classes. For that you have to make sure that you are subscribing the channel so that you are not missing anything. Fine, 100. So for a solenoid, what is the formula for a long solenoid? When I am talking about a long solenoid, what will be the self-inductance formula for that? Let's see. You remember for an ideal solenoid was what? A very long solenoid. That is what the approximation that we have put. So what is the formula of magnetic field? Firstly, let's understand that. We can derive here only. There is no such big derivation. I can say self-inductance is basically what? Flux divided by current, correct? And if n number of turns are there, you will multiply it by number of turns, that is n. Okay. So if I am writing, what I can write for flux? Flux can be written as B, that is magnetic field, into area. Area, how you will be writing? What will be the area? The radius is given as r. That means the area you can write it as pi r square. You will be writing it as pi r square. And if I will write the magnetic field also directly, I should write magnetic field for an ideal solenoid, that is equals to mu naught ni divided by I, and there is a multiplication of number of terms. This I got cancel. And what is the small n? Small n is what, if you remember, it was number of turns per unit length. So if finally I have to write the result, I can write the L value is equals to, at the place of n I am going to substitute from here N can be written as small n into L. So just substitute that result, and what is the final result that you will be getting? You will be getting mu naught n square pi r square into L. This will be the final result that you will be getting, n square pi r square L. I hope that I have not missed anything. This will be the final result. That if you want, you can remember, otherwise it is very obvious result also, you can derive it with no time. Mu naught n square pi r square into L, exactly the same thing. Okay, so let's see here what is the question is saying. If the number of turns per unit length of a coil of solenoid is doubled, the self inductance of the solenoid. It is a proportional question. Just you have seen it was L was equals to mu naught n square into pi r square into L. So if I will be talking only about the variation of number of turns per unit length, I can say simply what? L is directly proportional to sorry, if I am talking only about variation of number of turns, I can simply say L is directly proportional to n square. So if I can say n is directly proportional to n square, and now what you are making it, you are doing it double. If you are making it 2x, what will be happening with the inductor? It will be becoming 4x, correct? So I can say it will become 4 times option D. Simple. Otherwise, if anyone have problem, they can go from the conventional method, take the ratios, you can solve by that way. Initial and finally what you will say 2n whole square, that means 4n square. Here you will say L dash will be coming equals to 4L. That is the same thing again. If you want to do that, those are baby steps, you can do by yourself, I hope. Okay, 4L, this is the step that I was telling you about. You can write by this way, this complete method, but we know that much of basic proportionality, I hope. Now there are two types of circuit. One kind of circuit is growth circuit. Growth circuit means current is increasing. Initially current is 0 and now current is increasing. That means inductor is getting charged. Okay. Second kind of circuit is decay circuit, in which current is continuously decreasing. That is, if you want to resemble this from capacitor, in capacitor we have studied two kind of circuits. One was charging circuit, second one was discharging circuit. Same kind of things will be happening here also. So here we are going to use a little bit of KVL also, so be ready. It is a good derivation, I will say, so be with me, and if anywhere doubt you can just ask me in the right at the moment. Okay, let's begin. What the concept is. Very easy, there is nothing now much. See, what is this circuit? Firstly, let's try to understand. There is a option here to connect either with S, either with B for the key. Okay, so there is no connection. That means this is the complete circuit that is present for you. Here is a resistance present here. Here an EMF is there. Here is an inductor is placed. Okay, and there is some current IS that is already shown for you that it is flowing. It is a growth circuit. So initially I will say current is 0, and finally let's suppose current is some I. Okay. I naught, final current, but I am calculating at some time t, at any some time t. Let's suppose the current is equals to I. Let's suppose some current is equal to general I want to generalize the equation of current. So how I can do, let's write it from the complete basic. If I will redraw that diagram, I thought that I have remembered that one was a resistor. If I am wrong, please correct me. Then there was an inductor. Inductor is shown like this. Okay. Then there was an battery of EMF E. Okay. And some current was flowing through it. At any time t, this is the current that is flowing. This is the in general current equation that you can write. Now let's write this. Apply KVL into this complete circuit. Let's start from this point. What has happened? Then pen gone. So let's again draw the circuit. There is one resistance, then there is an inductor, then there is a battery. Okay, and there is some current that is flowing that is current I. How you will apply KVL? Let's start from this point. Let's suppose the point is A. Now let's write the equation. Firstly, you are crossing this battery. How will be writing? Let's suppose the EMF that you will be writing after crossing is E. Then how you will write the potential difference across this resistor? You will write minus of IR. That is the basic potential difference that we always write. What is the potential difference across the inductor? Just we have studied about it. That is equal to minus of L di by dt is equals to 0. Now see what you can do. Take E minus IR on one side, okay, and take this L di by dt on the other side. Then what you will be doing? Let's break this into two sections. Here, take the I section on one side and take the dt section on the other side. Dt by L, and on the other side take it di by E minus IR. Integration will be initially, let's suppose current is 0, finally some current is I, initially time is 0, finally some at time t we are writing the current. Here it will be simply T by L. Here what will be happening, that is interesting. What is the integration of 1 by I? 1 by I will be simply ln of E minus IR. Ln of E minus IR, and if their coefficient is R, that means it will be divided by R also, and I am writing that R here. Is it clear? I am writing that R here, and I am taking that minus sign also. So if I am now putting the limits 0 to I, how it will be looking like? It will be looking like somewhat like this: E minus IR divided by, when I am putting I is equals to 0, it will become only E, correct? And on this side you are already having minus of RT upon L. Now what you can do, if you want to remove this, what you can write here, ln, if you want to remove, you can write it as 1 minus IR divided by E. Or keep it as it is. Better way, keep it as it is. We will write it in another way. See, this is base is E. That means how I am going to write. I will write E minus IR by E is equals to E power minus of RT upon L. Correct? And this L by R is defined as tau. Tau is what? It is a very important term that you have to remember. Tau is what? Time constant. It is what? Time constant. Then what I will do? I will write E minus IR is equals to E into E power minus of T by tau. I replaces that R by L as tau. And then what I will do? I have to find current. That means I will take this on this side. I will write what? E will be taken as common, 1 minus E power minus of T by tau, and that is equals to I into R. So finally current can be written as E by R 1 minus E power minus of T by tau. That is the result that you have to remember for growth circuit. And this term is also written as, this complete term is also written as I naught. So the general equation is also remembered as I is equals to I naught 1 minus E power minus of T by tau. Now there will be two cases. In how much time, how much current is passing through. So if I'll ask you, tell me at T is equal to 0, there will be two cases made. At T is equal to 0, how much current is there? Let's calculate. At T is equal to 0, I can say it E power 0. E power 0 means what? It is here, it is what? 1, and E power 0 is also 1. That is 1 minus 1 will simply get cancelled out, and the current that will be coming, that will be equals to 0. And that is a very obvious case also, because I have put it the limits. At T is equal to 0, the current is 0. Clear? Now so I can say, when it is at initial position, at initial time, can you say inductor is behaving like an open circuit? Isn't it? that inductor is behaving like a open circuit at t is equal to 0, because there is no current that is flowing through it. So all of a sudden, if there is no current and you have conducted an inductor, it is going to behave like what? Because this I am telling you, it will help you in circuit solving. In circuit solving, sometimes the conditions are given that you are solving it at t is equal to 0 or steady state. What is steady state? At t is equal to infinite, it is called a steady state. So what will be happening with inductor at steady state, that also let's see. Okay, so I can say at steady state, what is the time? T is equals to infinite. Now put t is equals to infinite, it is what? 1 by e power something I can write, and e power infinite, can I say this value is nothing but it will be tending to 1 by some infinite. If it is tending to 1 by infinite, I can say this value will be tending to 0. 1 by a very big number, that means it is tending to 0. 1 minus 0, it is 1, and that means I can say at the it is going to be equals to I naught, or it is equals to E by R. That means the maximum current is flowing through at what time? At steady state. This t is equal to infinite is called as steady state. Is it clear? That means at t is equal to infinite, what is the behavior of inductor? Inductor is behaving like a straight wire, and at t is equal to 0, inductor is behaving like a open circuit. This two things. Or short wire also, lots of time you can represent it a short wire as well. There is no problem. At t is equal to infinite, it is behaving like a short wire, and at t is equal to 0, it is behaving like open circuit, because there is no current that is flowing through the circuit. So both are the behavior that you have to understand for processing of circuit solving. Whenever the complicated circuits will be coming, at those time it will be helping you a lot. Okay, so now there is a derivation that here it is completely done the derivation. The result that you have to remember, I is equals to E by R, 1 minus e power minus of t by tau. Okay, the important term that you have to remember, again I am saying that that tau, time constant, a lot of time only questions are coming from the time constant only. So it is an important thing that you cannot afford to forget. All these things are the same. Okay, here is an important curve. When we have plotted the curve of this growth, what you can say, it is a variation of current by time. Current by time variation is given. At t is equal to 0, what was the current? 0, correctly represented. At t is equal to infinite, at some infinite time, it is tending to what? It is tending to complete I naught current. It is tending to I naught current. It is tending to I naught current. So, and one very important point is also there. When you are taking the t is equals to tau, when you are taking a specific time, that is time is equals to one time constant. Time constant already I have defined you. And if you are taking that at one time constant, what is the general equation that you will be writing? You will be writing I is equals to I naught 1 minus e power minus of t by tau. And the time at which you are calculating, for the calculation you are doing at 1 tau. That means at 1 tau, what you will be writing? 1 minus e power minus of tau by tau. It will cancel. That means it is 1 by e. 1 by e is having a value that you can remember also. It is equals to 0.37. 1 minus 0.37, that means how much it will be remaining? 0.63 I naught. So in just one time constant only, the current got introduced from 0 to 0.63. That means I can say current have increased by 63% in this circuit. Okay, current is increased by 63%, and same kind of variations were there in capacitor. If any student have studied capacitor charging and discharging circuits properly, they will be feeling this very comfortable, because this is the revision kind of thing for them. Results are also not new. There was just result was in terms of charging of current, charges, and here we are studying for the current. There is not much difference in both the circuits. So if you are studying any one of them, you are studying, actually you can tackle both of the cases. Okay, so the second case now is for discharging circuit. Let's tackle out that also. Decay circuit. Now, in what will happen in decay circuit? Decay circuit is for, let's suppose you are having a maximum current I naught that is already flowing into the circuit. Now you have disconnected the battery. You have disconnected the battery. You have discarded it, because now you have connected the section B to C. Last case, the section that was connected was this one. B to C was connected in this single wire, so that we have taken consideration. But now we have neglected that circuit, and now we are going to derive this. So let's again redraw this circuit. Fine. Let's see what kind of derivation is there. There is a resistance, there is a inductor of inductance L, and that's it. A current I naught is flowing through it. And now this time let's see what are the results that are coming. Again apply the KVL. In this time you have to apply KVL only for two things. What are those two things that you have in the loop? You will be writing the potential difference across this resistor. You will be writing it as minus of I naught into R, or I will say that let's suppose at some time t you are calculating this, so let's write it at general. Let's suppose at any time t you are writing this I at any time t. So how you will be writing the potential difference IR, and how you will be writing that across the inductor? You will be writing minus of L di by dt, that is equals to 0. Correct, that is equals to 0. Now let's derive this complete formula. Now separate on the both sides. Here what you will be doing, you will be writing minus of IR is equals to what? L di by dt. Correct. Take the dt term on one side, dt, and here it is what? Minus of R by L. Again I will replace, I am going to, you can understand now again I am going to replace it as tau. That's why I have written it on one side, and here I will be taking Li by I. Now integrate it. Integration initially from I naught current at t is equals to 0 to at t is equal to t, there is some current I that is I want to calculate. The integration is going to give you ln I, put the limits as well, from I naught to I, and here you will be saying that it is minus of RL into t. Now what you will be doing here, the putting the limits will giving you I divided by I naught, and here it will be still R by L into t. Now next step will be what? You want to remove this ln term, that means you will be writing what? I divided by I naught is equals to e power minus of t by tau. I again replace the tau as L by R, and now I can simply write I is equals to I naught, that is a maximum current, into minus of t by tau. It is equals to maximum of t by tau. Correct. Now this time if again I want to judge what will be happening at t is equals to 0. Let's see, t is equals to 0, that means what you will be saying, initial time I can say e power 0 is 1, that means at t is equal to 0 current is equals to I naught, and I have told you at t is equal to 0 maximum current was flowing into the circuit. At steady state, let's suppose what will be happening at t is equal to infinite. What will be happening? How much current will be flowing? It can be said as 1 by e power minus of t by tau, and 1 by e power minus of t by tau implied e power infinite. 1 e power infinite, that means it is going to tend as 1 by infinite. 1 by infinite is nothing but 0, that means at infinite time it is t is equals to 0. Let's also write at t is equals to tau. What will be happening at one time constant? That because I have told you that in complete curve there is one important point where you have to remember the result, that remember in growth circuit it was increased by a factor 63% in one time constant. In decay circuit, let's see how much current is decreased in one time constant. That is a very interesting and very important case. So satisfy t is equals to tau. T is equal to tau satisfaction is going to give you what? I naught into e power minus 1. That is can also written as 1 by I naught by e. And 1 by e, the result that you have to remember, 1 by e is equals to 0.37. That means I can say in one time constant the current in the circuit is equals to 0.37 of I naught. So can I say in one time constant current got induced by 63%, and in one time constant in decay circuit it is decreased by 63%, and the rest current that is available here is 0.37 I naught, and till steady state it is again going to be the current is equals to going to be 0. Samajh aaya? Is it clear? If any doubt is there, please tell me. Okay. Fine, let's move further. These two were the two important cases that I had to tell you for growth circuit and for decay circuit. The notes will be available for you. The derivation I've already explained you. Okay, step by step derivation. Baki these kind of given things you have to write in proper step. This is the important curve that you have to remember. There is no way that you can forget. Initially you will be marking this maximum current as I naught, and now continuously it is decreasing. At the end it is tending to zero current, and at one time constant the current is 0.37 I naught. Okay. Now the next and now we are towards the end of the topic. Let's discuss about mutual inductance. Now what is this mutual inductance? What is this mutual inductance? Self inductance we have understood, sir, but now what is this mutual inductance case? Let's understand mutual inductance. So mutual inductance is what? See, let's suppose two loops are very kept closer to each other. Two loops, one is primary coil, second we name it as secondary coil. What I am doing here, I will tell you. What I am doing, I am changing the current of this first circuit. What I am doing, I am changing the current of the first circuit. In second one, it is constant. There is no change here. I am only changing. I am doing some chhed with the circuit one, primary circuit. Okay, primary coil. Okay. So due to that change in current, what will be happening? Can you say magnetic field will be changing? And if magnetic field is changing, I can say flux is also changing. Flux is changing, what will be happening in circuit 1? If flux is changing in circuit 1, I can say that kind of concept is called as self-inductance. Very fine. But now understand, when second loop is also kept closer, the flux that is passing through this cross section is also passing through this secondary coil also, no? Because both of them are kept so closer that the flux that is passing through primary coil is going to pass through secondary coil. Now this flux in primary coil is changing. That means, can you say due to this primary coil, flux is now changing in the secondary coil. Current is not changing here. Current of the secondary coil is constant, but due to the primary coil, the flux is changing in secondary coil, and due to primary coil, EMF and current will also get induced into the secondary coil as well. That is the concept of mutual inductance. It is not induced by its self coil. Self coil, if it is induced, it is called as self inductance. But if it is induced due to some other coil or the primary coil, then it is called as mutual inductance. So inductance is same, but how it is generating, I hope that now it is clear. So what is the equation that we write here? We write here that the flux of coil 2, here we are naming this as coil 2, was proportional to the current of loop 1. That means we can define flux of 2 is equals to, because when we remove this proportion, there we got self inductance, where we are going to get mutual inductance into I1, and vice versa. We represent flux of loop 1 is directly proportional to current of loop 2, and we define phi 1 is equals to mutual inductance into I2. These are the two very important things that you have to understand. Rest of the theoretical things are given here only, so you don't have to worry for that. Okay. So same thing here also, it is represented flux linked in coil 2 is field generated by coil 1. In coil 2 it will be generated due to coil 1. All the formulas are given here. Phi flux in 2 due to 1 is proportional to current due to 1, and here I have told you flux in 2 is equals to M into I, that I1, that is going to be the formula. The rest of the things will be same, because it is also inductance, and self inductance was also same, so formula will remain same, unit will remain same, Weber per ampere. There will be no change there. Okay, there is a very basic question. Let's see what is the question is saying. The coefficient of mutual inductance of two coils, coefficient of mutual inductance M is given as 6 millihenry. If the current flowing through the one is 2 ampere, the induced EMF in the second coil will be. See here what the trick they have played. They have given you what the current. What is the about the information that they have given you about the current? They have very smartly they have given you the idea about the current, that it is flowing how much, 2 ampere. 2 ampere is a changing current or it is constant current? What you can say about this current? I can say simply it is what, a constant current. If it is a constant current, that means there is no change. That means I can say there is no change in flux also. If there is no change in flux, why there is self inductance, why there is mutual inductance? There is no story. because these things got induced when you are changing the current with time na, then only it was coming. Otherwise there is no point of discussing about mutual or self inductance. So that's why there will be no induced EMF in the second coil. That means answer will be what? Simply 0. If there would be some change, then we would have written about the formulas and rest of the things. I hope this will be clear. Very important question, because you will be getting so confused that, because generally we talk for the normal cases. Here it is abnormal case. Here they have played a trick that they have given you constant current, and now they are asking for induced EMF. I can assure you that 80% of students cannot think. When they will having this question for the first time, they will not be able to crack this question, that why this will be induced, because major of the time we only focus on the formula. This is the question that why I have given you. Understand the concept. From the first lecture I am shouting only one thing: change in flux, change in flux, change in current, all these things. Why I am shouting for this? Because understand the concept. There is no chance that anyone can answer that. Okay, you will be only confused. Okay sir, they have given me a formula that phi is equals to m into I1 or I2 depending on the coil in which you are calculating, and you will be answering from there. Okay, you will be not thinking one time also that why that EMF will also get generated. There is no point of generation. Correct now? This is what the whole story is. So there will be 0 EMF. EMF if I am talking about, just differentiate it, you will have your answer. EMF, if in coil 2 I am writing, EMF in coil 2 can be written as m into I1, and the formula after differentiating it will be m into di1 by dt, and here simply it will be getting m di2 by dt. Okay, here it is mistakenly E2. Okay, here they have only written for E2 only, EMF in coil 2. Same you can write for EMF in coil 1. It will be simply flux in coil 2 is represented as m into I1. So where the flux is written, in coil 1 it is written as m into I2. Just differentiate this equation, we will be having EMF in loop 1. Simple, vice versa. Okay. Both the results are here. Don't get confused into it. Okay, now there are lots of applications of mutual inductance. A huge application is there. The major application that we are going to, electric generator, AC generator, that is also a concept of inductance, that in this chapter only we are going to discuss how this AC generator works. Okay, alternating current generator. Alternating current is the next chapter, but about the generation of that current is what we are going to understand here only. Transformer is a very important application of mutual inductance. Specifically if I am talking about mutual inductance, transformer, biggest application that we are going to understand in the next chapter, current lecture. Very interesting thing, not current, sorry, alternating current. Okay, here we are going to study only about a transformer. I will explain you about what is this windings, what is this, how mutual inductance is coming into use. All these things we are going to study. Let's quickly understand about the series and parallel combination, because that is an important thing that we have to understand. Series combination of inductor. What will be the formula? That is what I want to derive. Anyways, series combination from spring to resistor to capacitor, all the times we are doing the same thing. So we are interested in the formula. So tell me what will be the series combination and what will be the parallel combination. Okay, so all these things, we know one thing, that current is going to be same way both the inductors, and the potential difference will be different. Okay, so using that I can say that E is equals to what? E1 plus E2. Net EMF of the circuit is going to be equals to E1 plus E2. Very obvious thing. How I will be writing the net EMF? I will be writing it as L di by dt, and current is going to be same. And for net EMF I will be writing it as L equivalent. How I can write E1? E1 I will be writing L1 di by dt plus L2 di by dt. L2 di by dt. Then what I can do, di by dt will simply get cancelled out, and from here I can say that L equivalent will have a simple formula, L1 plus L2. As simple as that. It is same as the formula of resistor, no worry. Better result for us. So it is resembling with the resistor. Even the shape also, it's a lot of times looks like a resistor. Resistor will have only conical kind of curves, and it will have a rounded kind of curves. Okay. So here is the result for you. If n number of resistors are inductors are connected, now you are very smart for that. You'll be simply adding up till n number of inductors. Clear? Actually, there is a term. If I will tell you, I will go in the depth. Then there is a term of plus 2m also. but majority of the cases we neglect that term. That's why I'm not introducing here. But if anyone interested, please comment down that in the comment section. We will be discussing about that also, because in some books they will be giving, so don't get confused from there. Okay, it is keeping it the thing simple. Parallel combination. Parallel combination, let's see what is the result for parallel combination. From all the time we know that what is parallel combination. Potential difference is same, current is going to be distributed. Current is going to be distributed, that is what I can say. Here is the distribution given. What I will say that I is equals to what, I1 plus I2. So let's write what I can write. Current can be written as what? Current will be written as EMF divided by the current you can write as L di by dt, that is equals to EMF, correct? And I can differentiate this equation, and I can write di by dt is equals to di1 by dt plus of di2 by dt. So I will write in terms of di by dt because we know about in that term only. So what I will be saying, di by dt is equals to E by L equivalent is equals to what I will say about di1 by dt. di1 by dt, what is the potential difference? E. What is the inductance? L1 plus, how I will be writing di2 by dt. di2 by dt, di by dt is what? EMF divided by the inductor. What is the EMF across it? It is again E. And what is the inductance? L2. E simply get cancelled out, and the parallel combination formula is coming same as the parallel combination of what? Of the resistor. So formulas are easy for inductor. Actually in capacitor, when we have studied, capacitor got a reverse formula. If anyone remember that, capacitor got the reverse formula, so there was a little bit tricky part, but here it is very simple for you, easy for understanding purpose, not any new formula. Parallel combination 1 by R equivalent is equal to 1 by R1 plus 1 by R2. And if n number of parallel combinations are present, now you are very smart, you can do it very easily, because we have studied a lot in depth about resistance and resistors, that we don't need to go in that much of depth for these kind of circuit combinations. If we have to write energy, let's write about energy also. Why to skip that? Tell me, my students, how you will be writing energy. You know that a lot of time we are writing energy as dW by dt is equals to what? V into I. Energy was defined as V into I, and energy can be written as dW by dt. So dW can be written as, work done can be written as E into I into dt. And what is EMF? EMF is nothing but L di by dt into dt, correct? So I can say dt will get cancelled. dW integration will be integration here for L is there, I di integration. That means here integration is going to give you work done. Work done is equal to what? L I square by 2. That will become the very good formula that you can remember. Work done is equal to half Li square. That is the formula. The energy stored in the magnetic field generated in the inductor due to the flow of current is equal to, due to the flow of current, how much energy that is generated in the inductor, that is defined as half Li square. Simple formula. Okay, from the basics you can derive also, and either you can remember this complete result, half Li square, correct? Try to solve this question. Read the question. What is given? A magnetic potential energy stored in a certain inductor is 25 millijoules. When the current in the inductor is 60 milliampere, the value of inductance is, remember the value is 25 millijoules. Energy is, solve karo. Energy is given as 25 millijoules, and what is given else? Current in the conductor is 60 milliampere. Okay, so calculate what will be the inductor. What is the formula that you have studied? Work done is equal to half Li square, and what you have to calculate? L will be equals to 2 times of 25 into 10 power minus of 3 divided by, here I square will be going what, 60 into 60 into 10 power minus of 3 into 10 power minus of 3. This 10 power minus 3, 10 power minus 3 will simply get cancelled out. Here it will become 50, here it will become 36 into 10 power minus of 1, because this are 100 and it will make it 10 power minus 1. Here it will be going, it will be 500 by 36. 500 by 36, what should be the rough answer? Because in the exam also we are not going to calculate the exact answer, so can you rough it around? 10 times it is going to give you 360. That means I can judge approximately it will be 13.89 Henry. Let's check the answer. It should be equals to nearly 13.89, exactly what we have estimated the answer. So a lot of times there is no need for complete calculation. Specifically in the competitive exams, you don't have to prove anyone that you know the complete calculation. You just have to estimate that which answer is coming roughly around. Okay, now let's calculate about generator. Okay, what is a generator? Generator is basically defined as, it is a machine that convert the mechanical energy to electrical energy. That is defined as generator. For example, if you have seen dam, what is the phenomena that is occurring, how we generate hydroelectricity, that there is a huge amount of water is falling on, there is a machine, there is called turbine, and when that turbine rotates, it creates that it channelizes the mechanical energy into the electrical energy. There is a complete setup for it. Okay, here we are only going to understand about the alternating current generator, how we generate that current. Okay, so let's see about AC generator. AC generator is follow the principle of Faraday's law. Okay, and how that follows everything I am going to tell you. This is the construction. You can even remember this diagram. What are the components for your board exam? It will be very important. I will tell you directly what will be the, how you can get to the results, a very easy way. Okay, I will telling you. Just you have to remember this. The rest of the things I will be telling you what you have to, how you have to derive. See, these are the components. This is a slip ring. Okay, this is a slip ring that always rotates. Okay, this is a carbon brush that is always connected on the both side. This carbon brush will be there, that will always be connected in connection with both the magnets. These are the two strong magnets, that is very obvious thing, and this is called as armature, that is rotating. Okay, and there will be, of course, if there is a north pole and south pole, there will be a very strong magnetic field from north pole to south pole. Okay, and now what we do, here are the uses that are given here. You can remember this as well. Okay, I will tell you about the how it is derived. Let's understand here only. See how this, when the slip rings are rotating, what will be happening. Okay, see, there is a very strong magnetic field from here to here. I will represent this like this so that you can understand easily. There is a magnetic field. Okay, and there is a loop we have taken of cross sectional area A, and let's suppose the number of turns is n. Okay, and now what we are doing, we are rotating it. We are rotating it. That means if I will ask you, tell me what you will be writing as flux. What will be writing as flux? Try to write the flux. What will be writing? Sir, there will be some magnetic field. Okay, very good. Write that magnetic field into some cross section area that is rotating. So let's suppose the cross section area for this thing is already given as A. Into, you know that it is when the angles are continuously changing, we write B dot A. B dot A is what? Dot product. Dot product will always introduce a cos theta term as well. Dot product will always going to introduce a cos term. So if you are introducing a cos term, you will be writing cos of theta. And if it is rotating with some omega, what you will be writing? Theta is equals to omega into t. From the circular motion, we are reading this formula. So I will be writing it is equals to omega into t. We have written flux. Clear? Basic thing. Now, according to Faraday's law, what we know about, because we want, it is a generator, that means it will be converting this mechanical energy into electrical energy. For converting electrical energy, I have to got some EMF into the circuit, then only I can generate electricity. So how EMF will be generated, that is where we are interested in. So I can say EMF that I understood from Faraday's law, that was equals to d phi by dt. Magnitude wise I am going as of now, I am not entering into the direction. Okay, d phi by dt. So that means what I can say, I have to differentiate this equation. Okay, fine. Let's differentiate. Before differentiating it, because there is n number of terms will also be given to you, so you can multiply n number of terms here only. Now let's differentiate it. Rest of the things are constant. BAN. Differentiation of cos omega t is going to give you what? Sine of omega t, and then they will apply chain rule. That means differentiation of omega t is going to give you an extra term omega. That means if I will be properly writing it, it will be equals to BA omega n. You can, in shortcut, you can also remember it as born into sine of omega t. Born into sine of omega t. It is also represented as E is equals to E naught. All these terms is represented as E naught into sine of omega t. So this is what the EMF AC generator, what we call it as AC generator. If I will ask you current, I will be writing current will also be written as simply E naught divided by resistance into sine of omega t. We are going to understand it is very much used in alternating current. From here you can say that we have entered into the section of alternating current, because why we say actually it as alternating. Okay, alternating current, if you know even the little bit of basics also, alternating current means what? The property of alternating current is it keep changing its direction. Sometime it will become positive, sometime it will become negative. In this way it is going to keep changing its direction. So what here you can see one more thing very interesting, that it is what kind of function? I can say it is sinusoidal function. That means if I will draw the curve of this function, how I can draw the curve of the EMF E value with time? I can draw this kind of curve. Sinusoidal function. That means I can also say that from here also, in this section it is positive, in this section it is negative, in this section again it is positive. That means I can say it is constantly changing its direction as well. Same I can say for current is also a sinusoidal function. That is what the basics of the next topic, that is alternating current, very important one. So this is the conclusion that I have to tell you. Rest of the things are theoretical, that how you will be writing a working principle, all these things you have to mention in your exam paper. Here is you have written flux, and then again you have differentiated it. After differentiation you are again going to have the same result, E is equals to E naught sine of omega t. And the same way you can write for I also, just divided by this resistance, you will be having your result. That here you can see it is a sinusoidal function. That means some portion it is positive, negative, positive, negative, positive, negative. This kind of function you are getting. Okay, so this kind of, and there is a very important value is also given. In India, the frequency at which these cycles are present is 50 Hertz. This is the frequency that we used to get in India. Okay, now students, tell me what is the frequency of current that is supplied in America? Okay, anyone had the idea? If anyone knows about it, please tell me in the comment section. Okay. So there is a basic question. Try to solve this question, and that will be the last question for this chapter. Finally we are going to end this chapter. Okay, we are going to nearly complete the magnetism portion also now. Just only the little bit of parts are left, as alternating current will be covering. Fine. In a region of uniform induction, magnetic induction, here B is equals to 10 power minus of, firstly we have to write the results, 10 power minus of 2 Tesla. A circular coil of radius 30 centimeter. Radius is equals to 30 centimeter. And resistance of pi square ohm. Resistance is given as pi square ohm. Okay, what you want to ask from me is rotated about an axis perpendicular to the direction of B, and which forms a diameter of a coil. Okay, and it rotates. Frequency is given as 200. Amplitude of the alternating current induced into the circuit. Amplitude is what? I naught, the question is asking you. The more you will understand in the next chapter, but still I naught, if you, the question is asking you, last case you remember that how we have written I is equals to I naught sine of omega t. If you remember, I naught was written as how E naught divided by resistance. And what was E naught? You remember what was the values that we have substituted? We have substituted B A omega n divided by the resistance. That's it. This is what your current amplitude. This is what your current amplitude. Now just substitute the values. All the values are given. I guess 10 power minus 2 is the magnetic field area vector. Cross section area you can write, radius is given, that means you can write pi r square into omega. Frequency is given, that means you will be writing 2 pi f for that, and then you will be multiplying it with the number of turns if it is given, otherwise divided by resistance, that is given as a pi square ohm. Pi square ohm. There is no value that is given for number of turns, that means you will be not using that, no problem. So when you will be solving, you will having your answer. Let's see what is the answer that is coming. Here I have told you this is the same thing. After solving this complete, you will be having the result as 6 milliampere. You can put the values and you can check it. It will be coming 6 milliampere. Okay. So this was all about this chapter, electromagnetic induction. I hope that you got to learn a lot of new things. It was completely interesting. Directions were important. If I will tell you, I will summarize this chapter. It was complete game of directions. Okay. Whenever you are watching this, watch it from the first lecture, so that because this chapter is in complete connection. I can say most of the chapters are in complete connection. If you are missing the first lecture, there is no point for watching the third lecture directly. Okay. So I hope that you will be learning with us. Keep learning, keep growing with Tapasya, Endigu and then Digu Nama Tapasya.